Imagine you tweak a prompt and now you have 200 outputs to check against your rubric. Scoring 20 by hand is fine. Scoring 200 every single time you make a change is not. That's where LLM-as-Judge comes in. Instead of grading every output yourself, you use a second AI call, handed your rubric, to score the outputs your prompt produces. Done well, this lets you run a full evaluation in seconds and rerun it after every edit. Done badly, it hands you confident-looking numbers that are quietly wrong. This lesson is about building a judge you can actually trust and the specific biases that make a naive judge unreliable. By the end, you'll know how to structure the eval, when a judge is the right tool, and how to check its work before you rely on it. An LLM-as-Judge eval follows a simple shape, and it's worth knowing the 4 steps cold. First, you run your task prompt on an input and get an output. Second, you send that output, along with the original input and your rubric, to a separate judge prompt. Third, the judge returns a score, and ideally a short justification for that score. Fourth, you aggregate the scores across your whole eval set into one number you can track over time. Here's the detail people miss. The judge prompt isn't something new. It's the same rubric as instructions you built in the previous lesson, wrapped so the model returns a structured score. Asking the judge to justify its score in one line before giving the number improves the score's quality and gives you something to audit when a number looks off. Not every evaluation needs a judge, and knowing the difference saves you time and money. Reach for an LLM judge when the criterion is genuinely nuanced. Things like helpfulness, tone, clarity, whether the response follows instructions, or whether an answer stays grounded in its source. These are exactly the kinds of judgments a script can't make, but a capable model can assess reasonably well. On the other hand, if a programmatic check would do the job, use that instead. An exact match, a keyword check, a JSON valid test. Those are cheaper, faster, and they're not subject to any of the biases we're about to cover. Save your judge calls for genuinely subjective quality and let simple code handle everything that has a clear right answer. A judge model is not a neutral referee, and research and practice in 2026 keep pointing to the same 4 biases. Position bias means that in a head-to-head comparison, judges tend to favor whichever answer they see first, regardless of quality. You control this by running each comparison both ways and only trusting a verdict that agrees both times. Verbosity bias means judges tend to reward longer, more elaborate answers, even when the extra length adds nothing. So add a rubric line that explicitly penalizes padding. Self-preference bias means a judge tends to favor outputs from its own model family. So when it matters, use a judge from a different family than the one that produced the output. And lenient drift means Pointwise scores tend to clump high and shift between runs, so lean on pairwise comparison for ranking decisions and rerun to check stability. Once you're controlling for bias, you still have to choose how to ask the judge to evaluate. Pointwise scoring asks the judge to score one output from 0 to 5 against the rubric. It's easy to aggregate and scales linearly as your eval set grows, but it tends to drift and clump toward high scores over time. Pairwise comparison instead shows the judge 2 outputs for the same input and asks which one better satisfies the rubric. It's more reliable because choosing between 2 options is easier and more stable for a model than assigning an absolute grade. The trade-off is more comparisons to run, and you have to control for position bias. The practical rule is this: use Pointwise to track your absolute quality bar across many versions, and switch to Pairwise when you need a confident verdict between 2 specific candidates. Let's look at what a well-built Pairwise judge prompt actually contains. It opens by telling the model it's an impartial evaluator comparing 2 responses, A and B to the same task, and that it should judge only on the rubric, not on length. Then it restates the actual rubric criteria, in this lesson's example, accuracy, completeness, and clarity. Next, it includes the task input and both responses to compare. Finally, it asks for two things in the output: one sentence comparing the responses on each rubric criterion and a verdict of A, B, or tie. And built right into the prompt is a note reminding you to run it again with A and B swapped, and to only trust a verdict that agrees both times. That's position bias control, written directly into the instructions instead of left for you to remember. Here's the step almost everyone skips, and it's the one that makes your eval trustworthy. Check that your judge agrees with a human. Hand score 10 to 15 cases yourself using your rubric, then have the judge score those same cases and compare. If the judge mostly agrees with you, trust it on the rest of the set. If it disagrees often, your rubric is too vague or your judge prompt needs work, so fix that first. This calibration step is what separates a real evaluation from a number that just looks rigorous. To recap, reuse your rubric as the judge's instructions: control position, verbosity, self-preference, and lenient drift. Pick Pointwise or Pairwise based on what you need, and always validate before you trust. Try it yourself right now. Open this lesson on Free Academy AI and run the Pairwise Judge prompt in the interactive playground, or paste it into ChatGPT or Claude.